Okay, so this is the first video in the series of VHDL tutorials that I'm going to be making. Let's close that. The scope of this first video is to just introduce you to the language and the structures, and then we're going to make a very basic combinational logic. So the first thing we start out with is library IEEE. People familiar with C++ will draw a parallel to using the # include and then a library. So this is basically the IEEE is the main library that has a bunch of all of the functionalities that we'll ever need. So the next we're going to use IEEE std logic 116.all. And then the use command, another parallel to C++. This is the same thing as like the using namespace, because this is a package in the IEEE library. So this is something like the using namespace std. So instead of having to do std : like cout in C++, you can just write cout. This is essentially the exact same concept. So now, entity. And then let's name it sample. Sample is... So this... So this right here is the skeleton for the entity sort of thing. Here in the ports, you know how you would declare your variables in C++, outside global variables? Well, these are like declaring the pins of the thing. So the entity is, if you're looking at the integrated circuit from the outside, all you're ever going to see is the pins. You know, we have 2 input pins, 1 output pin. And then this is just defining what the pins are called and their functionality. Nothing about like how the internal circuitry works. So right now, because this video we're just doing simple, extremely simple, whatchamacallit, extremely simple stuff. I'm an idiot. Extremely simple circuit. There we go. An extremely simple circuit, it's not going to be that much. So let's just have A as a... I'm going to write it first. So what in the world does this mean? So A is the identifier. That's going to be like, if you look at a data sheet, you know, you have your pins, like on the 74191, you have CLK, you have CTEN. That's just the name of it. Then in, even though this is the mode. So there are 4 modes, but we only need to worry about 2 of them, in and out. And then std logic is the type, because for combinational logic, all you really ever need is std logic, but as we get into more complex videos about sequential logic, we're going to be using stuff like integers, then unsigned, and that sort of thing. So B is another in std logic array in vector. So this, oh whoops, that's a reserved word. Let's do it Q. So this is basically, instead of having to write Q1 and Q2 as 2 different variables, we just have Q as a standard logic vector of 1 down to 0. So we have, this is a 2-bit array. Oh, crap. 1 second. So this is just basically an array that is 2 bits wide, and you can operate it on in different ways. So H. So notice here how on this last one we don't have a semicolon on this last line. That's because the semicolon already exists right there. So now we're done with the entity. Now it's time for the architecture, and this is where all the functionality is going to be. This is how your circuit behaves. You know, these are all the inputs and the outputs. This is where, well, the logic of the circuit. So architecture, I like naming it RTL of sample is architecture. So right now we have a squiggly line, and it's saying, you know, symbol A is defined, but its value is never read. That's just basically saying we haven't assigned it yet. So the reason I use a space here is because that's for signals and constants, which, while not important now, are going to be used in a later video for simplifying circuits and whatnot. And then we have begin and then end. So everything between begin and end is, you know, the behavior of the actual circuit. And then something that's really hard to wrap your head around is that in traditional programming languages, you know, it goes line by line. But in this case, every assignment is executed at the same time. So, but that means you can't like assign this one to be A and B, and then later assign it to be A or B. That's like a completely illegal statement. So let me just show you. So sum and it's that simple. That's how you make an AND gate. So you have the identifier of the output, this less than equal to A and B. And it really is just that simple. So sum or A or B. And it has every single type of logic. So we have, you know, XOR, NOR, XNOR, NAND, etc., etc. But another thing to note is that, you know, in traditionally, you know, math, you know, PEMDAS, right? Parentheses, you do everything in parentheses first, then exponents, multiplication, blah, 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 right? But in VHDL, when it comes to like ands, ors, nands, nors, there is no priority whatsoever. So if you wanted to do like a really big equation, like output A or B and C NAND D XOR E, right? You wanted to do something like that, you would have to use parentheses using like things. So ANDed with so this makes it legal, but before it was completely illegal. So Alex, what are you doing with these vectors? So there's two ways to like really operate on vectors that you probably won't really care about at all. You'll probably never use it ever. So big, we can add the vectors together, because you notice that this Q and H have a length of 2 each, and then this one has a length of 4. So if we do Q and % H, this basically just adds whatever Q is as the most significant bits, and then H are the least significant bits of this new bigger vector. And I can demonstrate that in the simulation. And then small, you can just operate on vectors. Like, let's do Q XOR H. So it's going to operate like it will do Q0 XORed with H of 0, and then Q1 for like the first bit, and then Q1 XORed with H1 for the second bit. So now that this is done, we have this handy tool here. It's called, it's called digital. Check. So this basically, I love this thing. It simulates VHDL for you, and it's great. So components, we add, now we have 4 outputs. Gotta change the size of this. There's 4 data bits, and I want it to be displayed in binary. So because I did that, I probably want to move him way out of the way. So here, give him 2 data bits, and then measure it in binary. Then this guy, and then now we have the, probably going to speed it up at this point. Okay, so now we're ready to simulate. Let's just play around with the, so, you know, ands and ors. We turn this on, because it's 0, 1, we have that. If they're both on, you know, basic truth table for this. So let's go, make this a 1. Since we have it, you know, being an XOR for small, and we have, you know, Q is the first 2 bits of this new big one, and H are the last 2 bits, so it's 0, 1, 0, 0. We see here 0, 1, 0, 0, and since we're XORing these two, you know, 1 XORed with 0 is still going to be a 1, but if we change the first bit of here to a 1, that's going to be a 0, and now we have 0, 1, 0, 1. So if I put it, and just make this here, yeah. So this has been like the first video on like, this is extremely basic, and then the next couple videos are going to like ramp up in complexity. I'm going to actually make circuits that matter. So yeah. I hope you found this, helpful, and see you in the next video.